We all run the most advanced blockchains. We have the most compute capacity of any blockchain. We have extreme throughput and fast finality. We're finalizing data on 600 to 900 milliseconds, automatic DeFi or AutoFi. This is probably the best business model ever in Web3. All right. Thanks everyone for coming. So the really cool thing about the Move ecosystem are that we all run the most advanced blockchains. Our designs are technically, frankly, better than what's been done before. Every single team I've seen that is using Move are very technical and are focused on performance. What Supra is doing today is different than what other blockchains have done before, though. We're doing full vertical integration. That means a single layer one that can do smart contracts, actually a multi-VM environment, cross-chain communication, automation, native on-chain oracles, as well as on-chain randomness, single stack, shared security. So we call this an all-in-one blockchain. So what is the problem? We know that there's a lot of latency when you have to use external services. When your layer one relies on an external network for price feed oracles or another bridge or an automation service, these networks are disparate systems. And therefore, every time you make a call out to them, you add latency. Those dotted lines represent additional latency. You call out to them, they have to finish their protocol and respond back to you. And this latency can be half a second, it can be up to a couple of seconds. And this will ultimately deteriorate your performance for your end consumers on your application. Now, we're pretty opinionated about this, that this problem gets actually worse in the layer 2, layer 3 world. Because now you have a layer 2, layer 3, and you have a data availability layer, execution layer, settlement layer, and you still have to deal with on-chain oracles, cross-chain communication, automation, different networks, disparate systems. It's slower, it's less secure, and it costs more. So remember, every additional network you use, you have more cost for the builder because you have to juggle all these extra tokens. You have broken security guarantees because you're no longer relying on the single layer one security. And also there's latency, so it's slower. It also makes the developer experience worse, right? Different frameworks, different languages, multiple tokens to juggle. And frankly, that's just the status quo. And we think there's a way to do better. So we're introducing a different way to build. Imagine a single layer one that has vertically integrated all these services. There's so many applications that need oracles or on-chain randomness or cross-chain communication or automation in order to do what they're trying to do. Most developers, when they're coming into blockchain, they don't realize that these do not come with a blockchain usually. Now, imagine a single layer one that's vertically integrated with these services all in one. Single platform. Right now, we are Move Lang based, right? And Move will always be the brain of our system. It's safer, and it's actually easier to program with. Nonetheless, we will be servicing the EVM and then eventually the Solana VM as well, and CosmWasm. Automation. Decentralized if this or that, or decentralized cron job services. What's happening right now is you actually have to have an external network that is monitoring the blockchain and then looks for the conditions, has to come to some agreement, sends a transaction into the mempool, and hopefully it gets executed and included for the automation task. These things add significant latency. Same thing with oracles. You can either pull it or you can push it, but these also add latency, and you're also depending on a different network for the security of it. Cross-chain communication is traditionally, a small committee of nodes for a bridge. It's not layer one security anymore. On-chain randomness, these are not, usually inherent in a blockchain. Blockchains are deterministic closed-loop systems, right? So we however, have devised protocols from scratch and put them all into a unique architecture to facilitate all these services in a single stack. So how do you keep your system safe? If you're running so many services in a single layer one, well, we have to shuffle the nodes periodically. So over there, you see clans. Clans are subcommittees of the tribe. The entire network is called the tribe. And we can do, if it actually is necessary, we can do a multi-tribe design, which are basically sister networks. But we don't think that's going to be necessary anytime soon. So imagine the whole system is called a tribe, and the subcommittees are called clans. We have to periodically shuffle them in order to maintain our security. So this makes it so that you cannot predict who is going to be running which service next, so it's hard to stage an attack. Moreover, once you form the clan, right, in our network, we actually have to run a DKG protocol, distributed key generation protocol. And once that key exchange or ritual has been finished, we have the clan. Those clans can now stay a clan for some period of time. And the different clans can be actually rotated to be doing different types of services. So for example, the VRF, verifiable random function, or the on-chain, or rather the Oracle, right? These are actually both stateless. So you don't have to synchronize state. You can actually switch between them very easily. There'll be other services like this as well. So we shuffle the nodes to keep the security. And then once we have the clans and they form their DKG, we can actually rotate them to do different services. Now, Supra has some remarkable results. Remember, all the folks that are move-based, frankly, are next generation. And we are also in that category. So we have extreme throughput and fast finality. How do we achieve such extreme results, right? It's pretty surprising to hit these types of numbers. This is run on a network of 300 nodes globally distributed. And the answer is the following. Every clan itself can be a committee that receives data and forms a data availability certificate. Okay, so the data availability proof can be formed on the clan level. And every single node on Supra can be a batch producer. So every node proposes a batch to their clan first. So remember, a clan is just a randomized subcommittee of the entire network, forms a data certificate proof, and then forwards the data to the rest of the network. It's enough for us to have the data availability quorum certificate formed on the clan level, a subcommittee, and then forward on to the block producer. The block producer actually only has a digest of the hashes of each batch, as well as the data availability proof of each of the batches. So actually, every single node can be proposing batches very quickly. It turns out the end-to-end latency for blockchain, the most of it is not execution. So folks focusing on execution, parallel execution, while that is very good, and we also do it as well, we have some remarkable results, the bulk of the latency is data dissemination and consensus. So, this is how we achieve it. The clans themselves are the subcommittee, a randomized subcommittee that actually only also need 51% to form a data availability proof. So we're talking about 51% of a subcommittee to form the proof, then we anchor into the blockchain, and then we run our Moonshot consensus protocol. Moonshot is considered the maximum you can take a classical BFT algorithm. So 500,000 TPS throughput with sub-second consensus finality, right? So these metrics are not including execution. We are going to be running additional tests, but all of us, we Aptos, et cetera, most of us, we measure it this way, and this is how we submit it to academic journals, et cetera. So the key, though, is that while, for example, Ethereum and Solana are focusing on trying to figure out how to do multi-leader protocols, most of us are already doing this, right? Every single node in our system is proposing batches, and then we run consensus on the block of batches. Remember, since they're just hashes of batches in the data availability proof, the block is small. The larger the payload is, the harder it is to disseminate. So, we do start with Move language. We're big fans of Move. We think that it's very good for the Web3 industry to move in this direction. Nonetheless, there are definitely existing applications and a lot of existing kind of work in the EVM and Solana virtual machine ecosystems, as well as Cosmosm. And we ask ourselves, well, can we run more than one VM? And the answer always comes down to, do we have enough bandwidth in compute? And the answer is yes, especially if you have a unique network architecture of the tribes and clans model. So, more or less, I think all of us are asking ourselves that, like, what can a single blockchain do? And it only comes down to, how much bandwidth and compute you have. And if you have enough, why shouldn't the nodes be not doing more? They should be doing more. So more or less, this is a design, single tribe with multiple clans. We're actually adjusting some of our designs along the way. We're constantly trying to iterate and learn. But imagine one clan is running our DORA, Decentralized Oracle Agreement Protocol. It's considered for its type of Oracle protocol. As far as we know, you can't really go faster than this at all. We're finalizing data on 600 to 900 milliseconds. We're not producing data that fast. We're finalizing it. VRF, verifiable random function. This is good for gaming, for loot boxes, lotteries. And then different clans can actually be executing different virtual machines. So our main insight is that, actually, this is a really cool insight, is that the entire tribe has to run the consensus. Super majority of nodes have to run consensus, but execution does not have to run on super majority. It can actually be executed in a subcommittee. And this major insights gives us the scalability that we're talking about and a lot of compute capacity. I would actually argue we have the most compute capacity of any blockchain with this approach. So we can run different virtual machines. And right now, it looks like we're running different clans for different VMs, and that is the existing plan. I just want to mention, we are thinking, however, that we could actually run all the virtual machines in a single clan. So we've been measuring this, and it's pretty surprising that you can compute a lot. So EVM needs to execute sequentially. We can parallelize that. We have results on that. And what's really interesting is this is very early, so I don't want to say that this is definitely going to happen, but we think we can actually run an STM-like execution across VMs, which enable us to have cross-VM composability. This would be a pretty major breakthrough. Okay, so moving forward though, of the things that are new and cutting edge at Supra, and the things that we're really focused on ultimately is execution quality for the end consumer. What is execution quality? It is, well, less MEV. It is timely liquidations. It is tighter spreads, right? So we have a very simple idea that is potentially very profound in terms of MEV protection. The key point though, what I'm about to share is that is zero latency. So first of all, MEV, toxic MEV, what is it? It's, you do things like front running or sandwich attacks. What ultimately happens to the end consumer is you don't get the execution you expected. You get slippage, you get worse execution. You can kind of feel it over time. And this happened a lot on Solana and Ethereum during the meme coin craze, right? And people were paying it because it was just kind of berserk how these things were going. So, but nonetheless, these types of things are not actually legal in the traditional world, as far as I know. And I think they'll also become illegal as we go mainstream. So this is a sandwich attack. What is our solution? Well, remember how we said that the clans can do DKG, right? They do DKG periodically. And by the way, our team led by Dr. Anna Kikate, who's literally an expert, or probably maybe the top expert in the field for DKG. It's actually how I found him originally. I was looking into DKG work in 2017. He had a paper called DKG in the Wild. But we perform DKG, and we actually have a novel approach that is faster and uses less block space. So we do the DKG, which allows us to have threshold signatures. BLS threshold signatures have this wonderful property that you can aggregate them into a single signature, but as long as one single honest node is present in the threshold, the output is unpredictable. So it's actually a really great source of zero latency randomness given for free. So imagine if the order of the transactions in the batches and the blocks were executed at random, right? Everyone has the DKGC. Imagine the threshold signature on the block itself or the previous state commitment itself was utilized as a randomness seed, and we have randomness. There are other chains that try to do fair ordering, but they're a different committee of nodes, and they have to run their own protocol, and then they submit the block or whatnot. This also ends up producing quite a bit of latency. But this approach here with native randomness through our threshold signature there's zero latency here. So we think that this is a great mitigation approach. Well, the thing is the astute hacker would say, well, if you're just going to randomize my transaction, I'm just going to spam your blockchain to increase the probability of my transaction landing where I want it to be. So we actually have to introduce a second component. The second component is localized feed markets, pioneered by Solana. And what's going on here is if you look at the light blue box, it's filling up. Imagine that's a smart contract and the transactions are trying to hit that. The fee at the bottom, you can see it's getting exponentially more expensive. So randomized execution coupled with localized fee markets so that if you try to have a lot of transactions hitting the same state, it gets very expensive. So this is a way to force them to back off. So this is a spam mitigation process. So we think these two things alone are going to be, to our knowledge, and as far as I can tell, probably the best MEV mitigation strategy out there, especially because it's low latency and it's not much compute. So what's happening in the current world, the status quo, a lot of value is being sucked away from the ecosystem. So you can kind of see the red dot in the center, and it's kind of getting shrunk. That represents value that's being extracted by external parties, to liquidators, to arbitrageurs, to external services, MEV bots, and that value does not necessarily come back into the ecosystem. So before I continue, I have to introduce a new idea that we're moving forward with, which is a network-owned liquidity. So instead of, you may have heard of protocol owned liquidity, where a protocol can have a little treasury or vault. We're going to do this on the network level. So it's a network treasury that will ultimately be controlled by decentralized governance, right? And this is a key point because it's going to explain the rest. So keep this in mind. So right now, what we are going to do is introduce new business models such that the value flows to the treasury, to node operators, as well as dApp builders and to the community instead. And instead of to external parties that are extracting value. So I did talk about MEV resistance, right? I'm not going to say it's a perfect solution. We don't know if it is. It probably is not, but it's probably pretty good. It probably is best, frankly, as far as I can tell. I know Swee's working on some stuff. I haven't had a chance to read it, but I'm glad to see that we all think that MEV is not good for the end consumer in the end. And for us to succeed as an industry, we have to deal with it. Nonetheless, node operators is a major source of revenue for node operators, right? So our node operators can be a little bit uncomfortable that we're removing this revenue source from them. The answer is might be, transaction fees alone, block rewards alone may not be enough, right? So we're going to be introducing some new business models. At Supra, we're very much focused on sustainability. Layer 1 with Oracle price view data and automation. What can you do with this? And remember, we have something called zero block delay automation. How does that work? At the end of every single block, we execute the registered automation tasks. So it's zero block delay as well, zero latency execution. What we can do at the end of every single block on a system level is execute a series of transactions that rebalance DeFi. So if we see an imbalance between any pools, we can tap into our network-owned liquidity, flash loan, or whatever we need to do to rebalance DeFi. The arbitrage revenue can get shared with the decentralized network, to the node operator, and to the dApp where the opportunity came from. So what's really interesting is that, blockchains don't usually have this, and we're the first to do it. We just launched it on a testnet recently, and it's pretty remarkable. We call this automatic DeFi or AutoFi. I think it's going to be a major category. They're effectively on-chain bots. They're not really bots, but they're smart contracts and they're a set of instructions that are executed every single block. And if we're able to achieve 2-3 blocks per second, imagine that being executed every couple times or a couple times per second. And that difference in the arbitrage opportunity is actually redistributed to the network in the ecosystem. Solana has, from a Helios node operator, they had a report. They said that last year Solana had around $147 million worth of arbitrage extracted. Imagine if we had that, we just redistributed it to the treasury, like 50% to the treasury, 25% to the node operators, and 25% to the dApp. We think this is alone a very, very compelling business model that's going to outshine and probably be orders of magnitude larger than transaction fees. But we also have another idea. A major issue with kind of DeFi in general is if a liquidation doesn't get triggered, you can have cascading failures. And sometimes these have to be triggered through external parties. But also, this is a reason why there's so much MEV, because the liquidation fee could be 1% of the position, which can be quite large. So 1% of $1 million position for just one transaction could be $10,000, right? And we know that there's billions of dollars of liquidations every year in the industry. But what we can do using our automation network at the end of every block is do auto liquidations. We have layer 1, we have Oracle price feeds, and we have automation. And we execute the automation at the end of every single block with awareness of the prices of these various positions. So if any position falls below water, we can flash loan from the treasury, pay back the position, make it solvent again. And then once again, that 1% fee up to 1% will be redistributed to the treasury, to the node operator, and to the dApp in which this opportunity came from. So I think that, and I'm actually pretty confident, not even pretty confident, I'm 100% confident, this is probably the best business model ever in Web3 because it's the most lucrative and it's fair. So MEV resistance with revenue share to the treasury, to the node operator, as well as to the dApp. The dApp could further redistribute it to their community. So we're excited about this because it's going to create a virtuous cycle and it's a truly, truly win-win-win situation. So yeah, once again, it's kind of, you have this revenue share to the dApp, to node operator, treasury. And the treasury, I do believe is necessary to build this up over time because, our block rewards are designed for, say, 10 to 12 years. But we have to think far ahead. And we have to imagine, what if we actually didn't structure this right? What if transaction fees are not even close to covering the fees to run the network in 10 years from now? Supra is a fixed supply token as well. So what's really interesting about this is I think we can build a huge treasury over time. And the network, through network decentralized governance, can decide what to do with that. It could be to reinvest into ecosystem. It could be to extend block rewards. It could be to, we could do things in the real world. We could say, hey, we're going to buy a building, whatever. Whatever the network decides to do, we can do. But the key point, though, is that we have a driver of revenue that is going to be orders of magnitude larger than transaction fees, while not relying on predatory tactics like MEV. Okay, so let's talk about your automation. This is the latest update that we've been pushing at Supra. The other one was what we call SuperNova. SuperNova is our layer 1 cross-chain communication protocol. Let me just briefly explain that. It's actually a bridge-less protocol. Our insight actually was kind of just off the cuff. We were kind of really deep, focusing on trying to figure out like new types of bridges. And then Dr. Kotick just said, well, why don't we just recompute the consensus of the chains we have, right? Because in the proof of stake world, if you think about it, nodes have to verify and register their public address to stake. So you always have awareness of who the active nodes are on the chains you interact with. And this information is relatively easy to get. So we get this information, our nodes have awareness of it. And what we can do is basically just recompute the consensus of the chains we interact with. So we can skip the bridge. And this is strictly more secure. It's cryptographically secure. So it's a very simple idea. And that's the case with many things in life and technology, that the answer is actually really simple, but it's hard to see. So back to automation, though. This is the other major thing that's on testnet now. Is what's really cool is these automations can be triggered by all kinds of information. And since we have Oracle, we have 500 data price feeds that is cryptocurrency, that's equities, is commodities. We're going to get things like sentiment analysis on chain. We're going to get interest rate cuts. We're going to get job reports. We're going to get world events. Of course, those are significant Oracle problems, but we have, we're kind of Oracle experts. And what's cool is you can say, hey, if the interest rate cut comes in below what I thought, and Bitcoin is at a certain, price, as well as some other variable, do this or do that, else if. So these scripts are run at the end of every block. They're not super sophisticated scripts, but it's a start, and we think that we can bring more sophistication to it. But what's really interesting about this is that these get executed with 0 block delay. If the conditions evaluate to be true, it'll be done, and it's virtually instantaneous. So we're the first to do this. We think retail is really going to like this because we're building interfaces. One team here at Dexlin, we work with them to work with a kind of an AI assisted interface to set your automation. So these are almost like on-chain bots. They're not quite bots, right? But they're almost like that because they're monitoring for the conditions, and if they evaluate to be true, it gets executed. We're really excited about this. This is a new feature. No one else, to our knowledge, has done this on a high throughput blockchain, and certainly not a layer 1 with smart contracts with Oracle and automation. The key point, though, is having the Oracle as well, so that you can have all this other information. And if you have that information securely on the blockchain, there's more variables in which you can create conditional logic. And this is, let's put it this way. My belief, I postulate that most gas in the future is going to be consumed by these automation tasks, not by humans, and that these will drive most of the on-chain transactions. This notion of AI on blockchain is, it's something, but this is kind of like a middle ground. AI-assisted automation through these automation tasks that get checked a couple times per second is frankly a game changer. And this automation allows us to have the auto arbitrage, the auto liquidations as a new business model. So while auto arbitrage and auto liquidation are executed on the system level for the treasury and redistribution of the revenue to the dApps and node operators and such, these tasks anyone can register them all. Basically, you could do limit orders, you can do discounted cash, DCA, right? You can do payments, you can do subscriptions. That's a big one, by the way. You basically can build Stripe very quickly with this combination of tools. You can do allowances, all kinds of things. So it's basically endless. And developers, they themselves can also automate all kinds of things for their application upon different conditions being met. So that's basically the story. Supra is Move language based right now. EVM is on our testnet, one of them. We think, once again, that Move lang is going to be slowly but surely dominant, and actually Web2 developers like it. They can pick it up really easily. I was speaking to some folks in our community earlier, actually someone that's a novice programmer. He's having so much fun with this, with the resources we produce as an ecosystem. He's able to pick it up very quickly, and I was surprised how fast he was able to make his MVP. And yeah, so that's basically all the time I have for today. And just once again, we're bullish, move Lang. Thank you.